Supplemental math videos from Circle Christian School. Means and altitudes. Of all the concurrent points, I think centroids are the best. So to find the absolute middle of a triangle, balance is the key. Think about mobiles. What makes them balance? Centroids will Robinson. Danger, 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 Will Robinson. Okay, Lost in Space fans will get it. Okay, let's start with what happens with a centroid. First we have midpoints. All the red are midpoints, so you start with the midpoint of every side. And because it's a midpoint, it means that both of the segments on the side of the midpoint are congruent. Now this is actually an equilateral triangle, but just to show that it's possible that not all the sides are congruent, that I'm going to give it different little tick marks. Okay, basically you're going to start with a midpoint here and you're just going to run it to the opposite angle. And same thing for between A and C. I'm going to start from that midpoint and run it to the opposite angle. And from C to B, same thing. Just going to run it to the opposite angle. And you'll see that they all meet at one place, the centroid. Now, what happens here is that the longer part of the centroid is always 2/3 of the whole, and the smaller part is 1/3 of the whole. And that goes for all of them. Longer part is 2/3, and the smaller part is always 1/3 of the whole line. That's what makes these guys really cool. They have a neat mathematical balance to them, which is of course why actually it ends up being the middle of the whole triangle anyway. So remember that this is 2/3 and this is 1/3 of the whole. So if from D to C here was a total of 15 centimeters, then from C to the middle, which I'll call G, from C to G would be 2/3 of 15. And just think about it. You take whatever's numbers here and you divide it into 3, which would give us a 5, a 5, and a 5. Well, 2/3 is going to be 2 of those, so that would be 10. And from G to D would be 1/3, the left over there, which is 5. And likewise, if you just have one of these, for instance, if I had C to G, let's say C to G equaled, let's say 8, then the two things that made up the 8 would be the 4 plus the 4, 4 times 2, and so that means that the shorter length, G to D, would be a 4, and together the whole line equals 12. Centroids are awesome. Alright, altitudes are basically how tall is the triangle from any base, and that height always works perpendicularly from the base. So I'm just going to draw to the top of the triangle here, and it's going to be perpendicular. That's how tall it is. Say likewise with any other base. It's a little hard because I can't turn the computer screen, but I think you'll get the idea. Okay, again, it's perpendicular. That's how tall. If you could turn the computer screen, that's what it would be. And this one here, let's see. And you'll see that they all meet at a common point also, called the orthocenter. Orthocenter. If you have an acute triangle, then the orthocenter is inside. If you have an obtuse triangle, then the orthocenter is usually located on the outside somehow. And the best way to show that is that if I had an acute triangle here, then the height of the triangle is actually happening on the outside. And then if you have a right triangle, then the orthocenter is generally going to be the made from the legs. And we can show that as an example also. Here's a right triangle. And the height would be up here, and the other height is over here. And if you had it on the base, it's there. So the orthocenter sits right there at the 90-degree angle. Okay, go out and check out your triangles that you see.